Okay, now let's check with division. Here we are going to divide two 8-bit numbers. And this is the code to divide two 8-bit numbers. What we are doing is we are taking one divisor and loading them into two different registers. In the similar way, we are initializing one quotient, and initially we take it as 0, and we are moving that one into some register. So here it is LXI H2000, means we are loading this data 2000 into HL. Now MOV A, comma M means moving the contents of that memory location. It means content of the memory location of 2000 into accumulator. So here we are taking a dividend and moving the dividend value into accumulator. And again we are incrementing this HL pair and moving the value of that HL pair content into the B, means now we are taking divisor into B, and we are move MVA C, means immediately we are moving some value into C. Here we are moving quotient value and taking it as 0. Initially the quotient is 0 in in the early stage of division. So we are loading 0 into C and done with initialization. Now we know that here we are doing division with subsequent subtraction, means subtraction goes on once. So as we know, in subtraction we take comparison. We used to compare, like if a less than b, like that we do. So similarly here we are doing, and here compare b means we are comparing the dividend with division, and whenever here it is jump if carry to end of the division, means whenever a becomes less than b, then jump to the end of the division. This we are reading. And subtracting b means we are subtracting the divisor from the dividend. Okay, and then we are incrementing the c for the quotient, because for every subtraction quotient increases from 0. And jump to the division loop, means repeat the loop until a becomes less than b. So this loop continues until a becomes less than b, like checking whether a is less than b. If less than b, then going to the end of the division, or else subtracting it, like a less than b, a minus b. Then we get a quotient. So to load that quotient we are incrementing the c, and then again repeating this. When a becomes less than b, means it comes to the end of the division, then we are going here move d comma a, means now we are left with remainder. So we are, means remainder means after subtraction the remaining one is remainder. So we are loading till now. We have those values in the accumulator, because accumulator itself says that accumulated value. So the final result is in a. So now this result is getting loaded into d, register d, some new register we are taking and loading the accumulated value. And for the quotient Alexa H2000, we are taking some new memory location and pointing this, because we are going to load this data. So move M comma C, means this C, the quotient value we are loading into this new 2002 address. And we are again incrementing the HL pair and moving the contents of D, I mean the remainder, into the new location at heart. Let's check how it works. Like assemble. See, here we got this like mnemonics hex code for this mnemonics. We know that Alexa H2000 is 3-bit, like every opcode is 1 byte, and this 2000 is 2 bytes, so 3 bytes, and every byte takes 1 cycle. So these 3 bytes take 3 cycles, like that. And even every byte takes 3 addresses. So this is 3 addresses, it took 0000001 and 002. And similarly, all this. So now let's give our dividend, divisor, quotient, and remainder. And here we started with 200. So let's take in 200, let us for suppose give 81, and in 2001 for suppose take the divisor as 20, and in 2002 let's give the quotient. Initially let's take it as 00, and we want the result in 2003. So let's check. So the what we got is we taking 81 as dividend and 20 as divisor. We got the quotient 4 and remainder 1. That's it. Even we can do the same by step, but here I did run out. Yes.